Okay, this is the notes that I'll be covering in class for 2.8, and this is absolute value inequalities. Now, to this point, we did absolute value equations, and then we've also talked about inequalities. So this is basically putting those two concepts together. Now, the one thing that you have to remember is any time that you're working with absolute value, you have to consider that there's two cases. And if you remember in absolute value equations, we had to rewrite the problem and make it into two cases to solve. Well, for absolute value inequalities, you still have to consider two cases, but it depends on whether the problem is a less than problem or whether it's a greater than problem. Okay, so if the first problem I'm talking about is for a less than problem, okay? If it says less than or equal to, then this problem is going to be what we call an and problem. Now, when we talked about inequalities in 2.6, I did mention about the and problems and the or problems. So this is where this comes back in, and we have to know this information. But because we're dealing with absolute value, we also have to realize that when we solve, we have to consider that the absolute value could be negative or could be positive, because absolute value is measuring distance. So when we work on these problems, if I want the absolute value of some number to be less than a value, then that number has to be between the negative value and the positive value. So when we solve an and problem, most of the time our answers are going to end up between two values. Now, if we work on this problem and we make it be absolute value, so graphically what I'm saying is the absolute value of this number comes out to be a positive 6, then its partner or other absolute value number could have been a negative 6 in here. So if we're looking for the absolute value to be less than 6, I have to consider it could be at negative 6 or it could be at positive 6. And in either one of those cases, I would do it graphically, and because there's no equal sign here, I would have to put circles on the graph. And I want all these values that would be in between, because any of these numbers that I chose to be my x's, when I take their absolute value would always come out to be a positive number, but it would have to be less than 6. So that's how this information conveys itself. When we're taking absolute value and we want to be less than a number, it's going to be in between some numbers. Now, in this case, because we talked about interval notation the other day, interval notation just takes what's on the graph and puts it just in terms of numbers without a picture. So because the ends here are open, I would use parentheses on my two ends, and my only two numbers involved here is a negative 6 and a comma and a positive 6. So this, by interval notation, it's just showing you the numbers and the things involved on the number line without drawing the number line. We'll show it again as we work these problems. Now, here's what we have to do when we encounter an and problem. I know this one is an and problem because it has a less than in the problem. Okay, less than. So if you think of that, less than, okay, and, okay, and. We can make that comparison, less than, and. Now, here's what we want to do. You want to rewrite the problem. You're going to take the bars off of it, and you're going to put the middle part that was in the bars in between a positive value of 4 and its absolute value partner, which would be negative value. So you're going to write it so that now the problem has 3 parts to it, and it has 2 inequality symbols, and you still make the symbols both be less than symbols. So that's set up. Now what that says is your possibilities for answers are going to end up between what 2 numbers you have end up with on the ends. Now when we solve it, we have to solve it by a little bit different method, but mostly we have to realize that there's actually 3 parts to the equation rather than just 2 parts. So on a normal inequality, we would only have 1 inequality symbol in it. So since we put 2, We still are going to go back to the middle and we want to get x by itself. So I'm going to subtract 5, but this time I'm going to subtract 5 in all 3 places where there are number values. So now when I subtract the 5, I'm going to get negative 9 less than or equal to x, because the 5's subtract off, they'd be gone, and then less than or equal to 4, and a negative 5 would be negative 1. So now the answer right here is showing us our answers for x have to be between a negative 9 and a negative 1. So now if I'm going to put that on the graph, I'm going to just sketch negative 9 and put a number, and sketch a negative 1 and make sure I put them in the right place values. So then this would be 0 somewhere over here. So on a graph, if you're having to do it on a sheet of paper, for me, I would at least ask you to give me a reference point for 0 and then show me where the other 2 numbers are going to be. Now this says my numbers can be equal to those, so this time I'm going to put a solid dot on each of these. And I want everything that's in between those 2 numbers. So now when you shade, you're going to shade everything in between those 2 numbers. So any number that you would pick out of those, when you stick that back in, it would be a true statement. Now for the interval notation part, we're just going to take what we have on our graph and we're going to use it in just symbols. So I know that the ends can be included. So for interval notation and inclusion, you use brackets. Okay, they're squared off. Up here we use parentheses, so they're curves. Here they're squared off. So now I have a negative 9 on one end, and it's included, so it's bracketed. And on this end I have a negative 1, and it's included, and so it's bracketed. So this is what my interval notation looks like as a picture for that graph. Now in the college algebra, almost all the time your answers would be written in interval notation. You might need a graph to sketch and see what it's going to be, but your answer would look like this. So I'm giving you and showing you both ways so you'll be prepared for that. Okay, now case 2, these would be less than problems. Okay, a less than problem, we're going to rewrite it and we're going to put the partner on the right end and the other partner on the left. Okay, so 4 is out of the problem. Its partner goes on the left, and then we put everything in the middle, so we work it out here. Now, when we do a second case is when it's an or problem. So it's either greater or greater than, okay, or greater than or equal to. Now, this is what we call an or problem. Now, one of the ways that you can remember that is the word is greater. There it is, greater. So if we're using greater, we're going to make it an or problem. If we're using less than, we're going to make it an and problem. And each problem has to be worked differently because they fit in a different category. So on this problem, if this says I want all the numbers that are outside, that means greater than some value, then that means I'm going to be outside those words. So if I have 2 numbers on the number line, these numbers, so here, if my absolute value answers, every number has to be bigger than 3. Here's my 3, and here's my negative 3. So if I take the value of any number that's outside of this, and I'm going to put a hole here because it doesn't have equal, or I take the absolute value of any number that's outside of this, when I take that absolute value, it will make this statement be true. So notice what happens. On an and problem, it's the answers are in between the 2 dots. On the or problems, it has to go 2 separate ways. And your answers should reveal that based on where the arrows point. So this says negative 9 has to be smaller than the number that you put right here, but that number has to be smaller than the number you put right there. This is a little bit different. Now what happens is we're going out here where numbers don't stop, and we're going out here where numbers don't stop. So what we have to use to represent that is an infinity symbol. So that'll be representing infinity. Well, so interval notation, because we have 2 separate graphs, we always work left to right. So on the left-hand side, this is just going somewhere where I don't know, and we don't know where it stops, so it's a parentheses. But it's going in the negative direction, and it will keep going forever, so I use negative infinity to represent this end, this arrow. Then it comes in the graph, and it gets to -3, but it's an open spot. So I'm going to come up here to -3 and put an open parentheses. But because I have to add this to it, the place where you would normally write the word or, you're going to put a U, which means join them. Okay, and down here, this one's going to start at 3 and it's open, and it's going to go to positive infinity. So this would be what your picture looks like. This would be the explanation just all done in symbols. But you have two separate pieces, so you have to have two separate answers here. All right? Or is going to go opposite directions, and is going to go in the middle. So you have to look and see what the problem's telling you. Now here I have 2x minus 5 is greater than 7. So that tells me I'm going to have to set up my problem so that it works out like this. So I need to make two separate problems. One will be the positive version. So I'm going to go 2x minus 5 greater than or equal to 7. Okay, that would represent the end of the graph that's pointing towards the positive numbers. But now I need an end of the graph that's this way, and it has to be pointing towards the negatives. So my other equation is going to be 2x minus 5 less than or equal to -7. So if this arrow is pointing to the right, I'm going to be doing the positive numbers on the 7. If this arrow is pointing to the left, I would be doing -7 here. So whatever this sign, this number is, this arrow has to point that direction. Then you're going to solve each one. So plus 5, and I get 2x greater than or equal to 12. Divide both sides by 2. So x is greater than or equal to 6. So that's going to give me my positive end of my number line. So out here I'm going to have the number 6. This time it says equal, so I'm going to put a solid dot, and I'm going to shade this direction, and my graph is going towards positive infinity. Now here I'm going to do the same thing. I'm going to add 5, but the answer comes out different because I have a negative number on this side. Okay, so now I have 2x less than or equal to -2, and I'm going to divide by 2. So x is less than or equal to -1. So my other number down here is going to be a -1, but remember they have to go opposite directions, and so you have to make sure that your answer here is making it go opposite directions. So I want all the answers that are smaller or farther to the left than -1. So this time I'm going to put a solid dot here, and I'm going to go this way. Now when I write the interval notation, I'm going to slide it under the blank because I ran out of space here. So I'm going to start on the left. This arrow is pointing to -infinity, so it's parentheses, -infinity. Infinity on either end has parentheses. And it's going to come in, but -1 this time is included. So I'm going to put a bracket to put the -1 in there. And then to union it, this one is a solid dot, so I bracket that one. And it's at 6. And it's going to go everywhere to the right, so that would go to positive infinity. So there's your graph, there's your interval notation. Depends on what the answer asks for. Alright, so here's 6 examples of problems that we would have to do for the for solving inequalities with absolute values. So the first thing to do is to look at the problem and determine, is it and or? That way you know how to set it up. Okay, so this problem is a less than. Okay, so this is going to be and. That means I have to go back and I have to think, okay, I've got to put everything so that it looks like this. Alright, I'm going to put whatever's in the bars is going to go in the middle. So I'm going to put 2y minus 6 less than or equal to 20. And then on this side, I'm still going to write another less than or equal to, but the partner for 20 would be -20. Now when you work through the problem, you're just going to go, and first you got to get rid of 6. So you're going to add it in all 3 places. Alright, negative 20 and a positive 6 would be negative 14, less than or equal to, my 6 is gone, that'll be 2y. And here, less than or equal to 26. Now I get y by itself, so I'm going to divide each part by 2. And that leaves me with negative 7 less than or equal to y less than or equal to 13. Okay, so this is my answer in interval in regular notation. Okay, they call this set notation. Alright, now I'm going to put it on the graph. I want my answers to be between these two numbers, so I have negative 7 and 13, and they are equal, so I put solid dots on them, and then I shade everything in between. So for interval notation, solid means bracket and a bracket, and then this would just be negative 7 comma 13. Okay, so that's an AND problem. The answer shows up just like it is. Now, the next one, number 2, is a greater problem. So greater, this one's going to be an OR problem. That means I have to have 2 parts. Okay, I'm going to set it up just like this one on the other page that we did. Okay, it's going to be set up just like this one down here. Greater. Let me slide it up there. Okay, so we have to take our problem, we have to make a part with the positive number and the arrow points to positive, and then we have to make the part with the negative number and the arrows pointing towards negative numbers. So we do the same thing on this one. I'm going to make 2 separate problems, so I have 2x minus 3 greater than 5. Then I make 2x minus 3 less than negative 5. Solve each one. So I'm going to add 3, and I get 2x greater than 8, and divide by 2, so x is greater than 6. That gives me the right hand end on my answer. Then down here I'm going to add 3, and I get 2x less than negative 2, and divide by 2, I get x less than negative 1. So that gives me the left hand arrow. So over here on my graph, I'm going to put a 6, and I'm going to put a negative 1. And the 6 says I get bigger than 6. Okay, so it's going to have a hole because it doesn't have an equal sign. So I've got that end. And here I have a circle, and I have a hole, and I go this way. Now, interval notation, I have to do each end separately. Okay, so I would have parentheses, negative infinity, and it comes back and it gets to negative 1, but it's open hole, so I have parentheses. And then union, open hole at 6, and it goes to infinity. Infinity always has parentheses. Okay, number 3, less than, and it has a fraction in it. So less than goes back to like number 1. So this will be and. I'm going to put them together. So I'm going to have 1/2 x minus 3/4 less than the positive 5. And then over here, oh, it's not an equals. Don't put that on there. Negative 5. Okay, so whatever the number is after the symbol, you're going to put 1 on one end and the opposite on the other. Alright, now I have a common denominator. I need a common denominator that both 2 and 4 go into. So that would be 4. Alright, so here's what's going to happen. Everything has to get multiplied by 4. So 4 times negative 5 is just whole numbers. So that would be negative 20. 4 times 1/2. What's half of 4? That's easy. That would just be 2. Okay, when I multiply the 4 times the 3/4, This 4, remember, is 4 over 1. The 4's will cancel off, and I'll hit minus 3 less than 20, because I have to multiply 4 times 5 over here. Okay, got to multiply everything by 4. Now, in the middle, I can add 3 to both sides. I get negative 17 less than 2x less than 23. When I divide by 2, I end up with negative 17 halves less than x less than 23 halves. Now on this problem, because we're putting it on a graph, if you wanted to punch these in and get decimal values, that would be okay, because then you would be able to know kind of where it is on the number line. So negative 17.5 would be negative 8.5 or 8.5, and 23.5 would be positive 11.5. So if you wanted to do that, that's fine to get decimal answers, but you really don't even need to. You can just put the numbers on as fractional values and then put your graph. These are holes on the numbers, and it's and the x is in the middle, so I need it to be shaded in the middle. So our interval notation will be parentheses, negative 17 halves, comma, 23 halves, parentheses. Alright, number 4. And or. So this symbol is greater, so this one is another or problem. I'm going to take and make the problem separate, so this would be 3x minus 2 greater than or equal to 3. And then we have 3x minus 2 less than or equal to negative 3. Alright, these are simple problems to work. So you're just going to add 2 on both sides, and you get 3x greater than or equal to 5. And I'm going to divide that by 3. So x would be greater than or equal to 5/3. Over here I'm going to add 2, and I get 3x less than or equal to negative 1 divided by 3. X is less than or equal to negative 1/3. So now on your graph, this is positive 5/3. 3 goes into 5 one time with a 2 left over, so 1 2/3. So it'd be a little bit out between 1 and 2. And this one would be just a little out between 0 and negative 1. But I'm not even going to ask you to do that much to it. Just put the 2 fractional values on there. Okay, so they're both solid dots this time because they have equal signs. And this time the arrows go opposite directions because it's an or problem. Okay, so for interval notation, I really needed to move those lines down. So it's going to be negative infinity, comma, negative 1/3, and then union that with, bracket that one. I made a mistake right there. Bracket 5/3, comma, infinity. Alright, number 5 is a little bit different because notice none of the rest of these had anything with the absolute value. So here we have a plus 5. Before we can do anything, we also always have to get the absolute value by itself. So you're going to subtract the 5, move it over here first before you start. If you try this without doing this, half of the problem would be wrong. So I'm going to take the 5 and move it over first. That means the problem is going to look different. Now it's going to be 3x minus 6 is less than or equal to 9. So this is my new problem. I'm going to work with this one. Then I'm going to go back and do what I did up here. It's a less than problem. Okay, so this is and. So this goes in the middle, 3x minus 6, and on one end it has positive 9, and on the other end it has negative 9. Be sure that your symbols point the same ways. Alright, add 6 to both sides, or all three sides, sorry. This would be negative 3 less than or equal to 3x less than or equal to 15. Everything divides by 3. So I end up with negative 1 less than or equal to x less than or equal to 5. So all my answers have to be between negative 1 and 5, and they will be solid dots. So I put negative 1 and 5, and I make them solid dots. And my answers have to be in between those places. So my interval notation, they're solid, so I'm just going to bracket it on both ends, and I'm going to put a negative 1 in one side and a 5 in the other. Now remember, we always have to work left to right, so it has to be the left end and then the right end. Alright, last one here. This one is an OR problem because it's great OR. So I'm going to have to make two separate ones. So I have 4 minus 2x greater than or equal to 5 and 4 minus 2x less than or equal to negative 5. Now this one's going to be a little different because we're going to be dividing by a negative. And dividing by a negative makes us flip our symbol around. So we have to be careful on this problem, but it will still all work itself out. So I'm going to subtract 4. I get negative 2x greater than or equal to 1. I'm going to divide by negative 2. Now, dividing by negative 2 makes this symbol flip the other direction. So now I have x less than negative 1/2. That's going to be my left-hand end. So over here, negative 1/2, and it's dot, solid dot, and it's going to go this way. Okay. Usually on the others it turned out that side positive, but because we divided by negative, it flipped it all around. Which means this end is going to end up over here. So even though we use the negative on the 5, when we use the negative here, it's going to flip everything around. So now I'm going to subtract 4, and I get negative 2x less than or equal to negative 9. But I'm dividing by a negative, so x comes down. My symbol has to turn the other direction and go greater than or equal to, and negative divided by negative gives me a positive 9/2. Well, 9 divided by 2, that's the same as saying 4.5. So if you think about that in terms of the number line, it's going to be out here a little past 4. So you could call it 9/2 still, but it's going to be on that side. And it's solid dot, and the arrow goes to the right. So now I have two ends. So my interval notation will be negative infinity coming to a bracket negative 1/2 because it's solid. And over here would be bracket 9/2 going to positive infinity. Alright, the key is, can you tell whether it's an and or an or? And then you just have to look at the symbol. Other than that, the problems are not too hard, but you do have to think about it. So I hope you do well on these. Bye.